Hello, good morning children. After a long back, once again we are now meeting, and in this session we shall try to learn something about real numbers. Okay, to begin with, real numbers, it is union of irrational and rational numbers. Okay, now in this chapter we have different topics. So, first of all, we should concentrate on what we call Euclid's division lemma. Okay, now here Euclid's division lemma says that for given positive integers a and b, see, for given positive integers a and b, there exists a unique pair of integers, q and r, satisfying A is equal to BQ plus R. A is equal to BQ plus R. And this R is greater than or equal to 0 and less than or equal to B. So once again try to know what is Euclid's division lemma. For given positive integers a and b, there exists a unique pair of integers q and r satisfying a is equal to bq plus r, and r lies between 0 and b, or we can also say that r is greater than or equal to 0 and less than b. Okay, now to remember this equation, we can go for a simple mathematics. See here, division. So division of A with B. Okay. So quotient is say Q, and then for some integer, then we get the remainder R. So here this is called dividend. This is divisor. This is quotient, and this is remainder. So how we write this? This A is equal to B into Q plus the remainder R. Okay, so this is how we can remember what we call this Euclid's division lemma. Okay, now here we have one more algorithm basing upon Euclid's division, which we call it as Euclid's division algorithm. So Euclid's division algorithm is a procedure. It is a procedure to compute the HCF. HCF you know very well, highest common factor. So it is a procedure to find out the highest common factor of two given numbers. Now we will be using this Euclid's division algorithm to find the highest common factor of any two given numbers. Okay, we will begin with one example and we will try to solve few more problems from the exercise so that you will understand it in a proper way. Okay, so now what we are doing is we are trying to learn what is Euclid's division algorithm. Okay, so Euclid's division algorithm. Algorithm means step-by-step procedure. Okay, so now this is a technique with the help of which we can find out the highest common factor. So it is a technique to find or to compute HCF, highest common factor of any two numbers. Okay. Now we'll take one example and we'll try to find out the highest common factor of any two numbers. Okay. Now see, for example, let us take 130 and 80. 130 and 80. So what's that we are trying to do now? We are trying to find HCF, highest common factor of 130 and 80 with the help of Euclid's division algorithm. Okay, so this is our question now. Got the point? Now we'll try to see how we can find the what we call the highest common factor of 130 and 80. So among these 130 and 80, so 130 is greater. So we can take this as A and this as B. Okay, A greater than B. Now 130 can be written like this. Can be written as product of 80, the least number, into say 1 times plus 80 into 1 is 80. So 130 minus 80, we get remainder as 50. Okay? So 80 can be written as 130 can be written as 80 into 1 plus 50. Here this 50 is the remainder. So here this is A, this is B, okay, this is Q and this is R. Are you able to get my point here? Now again, we'll write this 80, that is we will divide 80 by this remainder 50. So 50, say again 1 times, 50 ones 50. So when we subtract 50 from 80, the remainder is 30. Okay. So this B, that is 80, is being divided by the remainder 50 here. Okay. Now again, this is A now, this is B, this is Q, this is R. Now we shall divide this 50 with the help of the remainder 30. So this is 30 into 1. That is 30. 50 minus 30 is 20. Okay. So here this is A, B, Q and this is R. Got the point? Now again, we will divide 30 with the help of remainder 20. So this is 20 into 1. 21 is 20. 30 minus 20, it is 10. So remainder here is 10. Then again this is B, this is Q, this is A as usual. Okay. Now again we will divide this 20 with the help of this remainder 10. So 20 is equal to this remainder 10 into 2. 10 to 20. So 20 minus 20, remainder is 0. So we have got the remainder 0. And we cannot further divide it as we got the remainder 0. Okay. So this 10, okay, divisor, so is called the highest common factor, HCF of 130 and 80 is 10. I hope you have got the point, how to calculate or how to find the HCF of any two numbers with the help of Euclid's division lemma. Okay. Now we shall do few more problems so that you can understand it in a proper. Okay. Now again, if you happen to go to the exercise, we have problems here. Say for example, HCF of 90 and 270. HCF of 90 and 270. We'll see how we can find the HCF of 90 and 270. Okay? So, HCF of 900 and 270. Okay, so find HCF of 900 and 270. So now we'll try to solve this. So 900 and 270. Among these two, clearly 900 is bigger than 270. So we'll write 900, we'll divide 900 with the help of 270. So 900 is equal to 270. So how many times we can divide this? So that's what we have to see. For example, 900 is there, then this is 270. So we'll think over, for example, 3 times. 300, 3 7 21, 3 2 6 7 8. Okay. So the remainder here is 90. Okay. So 270 into 3 times. So what is the remainder we got? 90. Clearly this is A, this is B, this is Q and this is R. Okay. Now we will take this 270. So 270. Now it is being divided by the remainder 90. So 90 into, very clear this time, 93 is 270. So 270 minus 270, the remainder is 0. So this is A, this is B, this is Q and this is R. So when we got remainder 0, we cannot further divide. So this B, that is the divisor here, is called HCF, highest common factor of 900 and 270. HCF of 900 and 270 is how much? 90. Okay, so this is how, using the what we call Euclid's division algorithm. How we got this? This is obtained from Euclid's division algorithm. Okay, so basing that, A is equal to BQ plus R. Okay, so that's how we have found the HCF of 900 and 270. We'll do one more problem. Okay, now here in your textbook, it is 3,800, HCF of 196 and some 38,220. So find HCF of 196 and 38,220. Among these two, it's again clear that this is larger than this one. So what we are doing now, we are finding the HCF of these two numbers here. So 38,220 is being divided by 196. So 196 into 195 times will give you this result. Okay. So both these are one and same. So this minus this, the remainder is 0. So plus 0. So this is A, this is B, this is Q and this is R. So what we have done, we have applied the Euclid's division lemma here. A is equal to BQ plus R. Okay. So now here we have got the remainder 0. So we cannot further divide it. So this divisor here, okay, 196 is the HCF of the given two numbers. Therefore we write HCF of 196 and 38,220 is how much? 196. Okay, this is one more problem. in order to understand how to find the highest common factor using Euclid's division lemma. Okay, now I hope you have understood finding the HCF with the help of Euclid's division lemma. Okay, now I'll give you two problems for homework. You try those two problems in a 100 pages notebook. Whatever you have listened, whatever you have learnt in this class, write all those points also and solve the problems that have been explained to you on the board. And in addition to that, you work out two more problems. Okay, so I am giving you homework. Okay, find HCF of 50 and 70, 50 and 72, 96 and 72, 96 and 72. How? Using Euclid's division algorithm. Euclid's division algorithm. Okay, if you happen to solve these two problems, okay, already you have been explained two examples here. So with this you can easily learn how to find the what we call highest common factor using Euclid's division lemma. Okay, we shall again meet in the next class. Till then, bye bye. Okay.